Have you ever thought how many people live in this world? And what if we take all the people and cut off their hair and start to count it? So let's see how many people live in this world. It is 6 billion. Okay. And what is the average hair? The average hair on a person's head is 10 to the power 5. So that means we have got 10 to the power 9, that is 1 billion into 6, it becomes 6 billion and 10 to the power 5. This is the number of hair if we take all the people living in this earth, and you know and all the hair also, so and cut off the hair, and we this is what we get, the number of hair. But why are we doing it? Let me tell you that there is another number that is called as a mole. Okay, a mole is a number that is 6.022 into 10 to the power 33. Okay, and this is a very big number, but many a times we don't get a feel of this number. Even by giving this example, you will tend to at least feel a bit of it, but not exactly how big the number is, because this number is very, very vast. Okay, so uh, 6.022 into 10 to the power 23. Okay, and we have read that in moles. Number of atoms present in 12 grams of carbon. Okay, 12 grams 12 grams of carbon C12, because there are other isotopes of carbon. So if you take, and that is exactly 12 gram. If you take these many atoms of carbon, that will weigh exactly 12 gram. Okay, so 6 into 10 to the power 9 to the power 5. Okay, this is the hair, but is it enough to read this number? Imagine so many hair and still you're not able to read this number. Okay, because if you count it, it becomes 6 into 10 to the power 14. Okay, so let's divide and try to find out. 6 into 10 to the power 23, this is this big number. And if I take all the hairs of all the people living in this globe, and if we cancel it out, we will come to know that it's 10 to the power 9. That means we require 10 to the power 9 globes, like ours. Then we'll be able to reach this number. But the important thing is that why do we need such a big number? Let me tell you that atoms, on the contrary, are very, very small, and in order to take a meaningful quantity of these, we need to take a number as big as this one. Now, for example, let's take 1 mole of hydrogen. Now, suppose that what I'm trying to say is this is my balance and this is my hydrogen atom over here. So, if we take 1 mole of it, so my hydrogen atom is 1 mole, and if I try to put some weight, where's the weight I need to put to balance it? I need 1 gram. So you can imagine these many atoms only weigh 1 gram. Okay, that means 1 mole of hydrogen atom taken will weigh only 1 gram, right? Do this thing over here. Okay, so my hydrogen atom is a proton and an electron. Okay, now what is the atomic mass? Atomic mass, by its very definition, or by its very word, it is saying mass of the atom. So what is the mass of the atom? An atom is 99.99% empty, and the mass resides in the nucleus. Okay, and my nucleus is made up of only 1 proton, so the mass, and we don't take the mass of the electron, because it's very, very small in comparison to the mass of the proton, so we'll take only a proton. You need 2000 electrons to make 1 proton in terms of its mass. Okay, so I will take the mass of the protons or the neutrons. So in this case we have got only a proton, so we'll take the mass of the proton. So atomic mass means the mass of the atom, and the mass of the atom resides in the nucleus, and in the nucleus of hydrogen we've got only 1 proton. That means the mass of an atom is the mass of hydrogen atom is the mass of proton. So we can say that this is the mass of the hydrogen atom. Let's take another one. If you take helium, okay, it has got 2 protons and 2 neutrons, and the mass of the proton um, is equal to the mass of the neutron. That means I've got 4 particles in it, 2 pluses and 2 neutrals. Okay, so I've got 4 particles. So what is the mass of helium atoms? The mass of 4 particles in the nucleus. In the same way, if I take And if I take sodium, okay, it's 23. That means mass of 23 particles, those are present in the nucleus, right? Now what is the mass of one proton? It is 1.672 into 10 to the power minus 24 grams, right? So now if somebody asks you a question, what's the mass of the hydrogen atom, you can tell him that it is 1.672 into 10 to the power minus 24 gram. What is the mass of helium atom? You will tell that since all the four particles are of the same mass or nearly of the same mass, you can say that 4 into 1.672 into 10 to the power minus 24 gram. So for sodium, you will say that 23 into 1.672 into 10 to the power minus 24 gram. But it sounds very clumsy. So you can do one more thing, that you can index 1.672 to 10 to the minus 24 gram as 1 unit. So somewhere if you write 1.672 into 10 to the power minus 24 grams as 1 unit, because every time you're getting this term, so you can say that my mass of hydrogen atom is 1 unit. Since I've got one proton or one particle over here, yeah, I've got four particles over here, I can say 4 units, and over here I can say 23 units. Now many a times student often say it as 23 units, but they don't understand how is unit unit of mass. Okay, so whenever I ask this question from the students, you say 23 units, but we know that when we weigh mass, then or when we talk about mass, we say that in grams. So where is the grams in 23 units? And they don't know it. So now if you're asked this question, you can tell that 1 unit is my 1.672 into 10 to the power minus 24 gram. The original value is 1.66, right? Now, this is my 1 unit, 4 unit, 23 unit. Or if you take any other atom, for example, gold, it will be 197 units. One atom of gold weighs 197 units. That's it, okay? Now, another term is molar mass. That means when you take 1 mole of the atom, what will happen? Or 1 mole of the molecule, what will happen? Okay, so this is my one atom. If I take 1 mole of it, now just taking a number, 6.022 into 10 to the power 23 of hydrogen atom. Now, if you multiply this number, I mean these numbers, what you get is 1 gram. Try to do it yourself, and you will get an answer nearly equal to 1 gram, that is 0.99 something grams. Okay, so I'll take that as 1 gram, and then since you have got 1 unit over here, multiplying these two, 1 over here, so it will give you 1 gram. In the same way, multiplying this by Na, what you get is 1 gram, and since you have got 4 particles, that is multiplying it by 4, you get 4 grams. So gram atomic mass of helium is 4 grams, and gram atomic mass of sodium is 23 grams. What you need to do is just look at the atomic mass and put a G in it, but you need to know how do we get this grams, 23 grams. It's not about mugging up or memorizing it. You need to understand it, and then you can just say it. Okay, once you understand these things, you're opening yourself up for difficult questions as well. you know okay, so 23 grams, right? Now, in the same way, gram molecular masses, GMM, that means mass of the molecules taken in gram. First, we'll take the mass of, suppose, say, water, and water is, suppose this is my 1 gram for one hydrogen, you multiply that by 2, and for oxygen, you have got 16 grams, you take it and it becomes 18 grams. Okay, now suppose that I take one molecule of atom, oh, beg your pardon, one molecule of water, H2O, how much that would weigh? I would take 1 unit for one hydrogen atom, since I've got 2 of it, and 16 units for oxygen atom. If I calculate it, I get 18 units. Now suppose that you have got 36 units and you're asked to find out how many water molecules are there in 36 units of 36 units. What you need to do is to divide by 18 units and cancelling units out, and you get 2. That means you have got 2 water molecules in 36 units. Suppose that you have been given 36 units, you are asked to find out how many helium atoms are there. You will put the mass of one helium atom, dividing it by this, you get 9 helium atoms. Okay, so it's as simple as that. Try to do it yourself, and you will find it that it's so easy if you understand the whole thing by this process. Okay.